Hello students, welcome to the video tutorial for informatics practices for class 12th. Today we'll be discussing the second part of the chapter plotting with PyPlot 1. So let's begin. First topic to be discussed today is basics of simple plotting. Okay, as in the previous video tutorials we had a simple example of plotting a graph. So we'll be discussing in detail that whatever the functions are provided in PyPlot, what capability they are having to show their functions over the PyPlot. Okay. Now data visualization also we have discussed in the previous video tutorials, that visualization basically means showing that data in some graphical ways. Okay. It can include some images, it can show some graphs, it can show some PyPlots charts. Okay. So whatever the data which is in some visual forms, okay, that is considered under data visualization. Okay. And some commonly used chart types which we are going to use at least according to our syllabus. Let's see what are they. First is the line chart. Okay. Now as we have discussed that in previous examples, also in video tutorials, that whatever the chart we had made was a line chart only. Okay. So what is line chart? A line chart or line graph is a type of chart which displays information as a series of data points. Okay. And this series of data points are known as the markers. Okay. And for connecting these markers we need a line segment. Okay. A straight line segment which should be connecting these data points. Okay. Now it depends upon where the data points are located. Sometimes what happens, these data points are so close that the line segment which is joining these data points may appear as a curve to you. Okay. So it is not necessarily true that it will look like a straight line, but actually we are drawing a straight line, but sometimes the data points are so close that it may appear like a curve. Okay. Also, you can see an example here of a line chart. See here the data values are given on the x and y axes and the corresponding graph has been plotted. Here you can see a line chart is there. See the data points are being joined with the help of a straight line segment. Okay. Now let's talk about the second type of chart, that is the bar chart. So what base bar chart is? A bar chart or a bar graph is a chart or graph that presents categorical data. Okay. And categorical data can be represented using these rectangular bars, and these bars can be either in the horizontal way or in the vertical way. Okay. And this what these bar graphs are showing, that heights or length are proportional to the values that they represent. Okay. So whatever the values are there on the x-axis, that particular values are shown according to the proportionality of the given function, and it is shown on the y-axis. Okay. So these bars can be either drawn vertically or horizontally. Third one, so let's see first example of also of bar chart also. See, this is a bar chart. Here we are having different categories: category 1, category 2, category 3, category 4, and corresponding values are given on the y-axis. Here we are also showing that which color is provided for which series. Okay. So like this we can draw any bar chart. Okay. We'll be discussing how to draw it with the help of programs, but right now we are just having a look that how this line chart are represented and how these bar charts are represented. Okay. Next thing is the scatter plot. Okay. So what a scatter plot is? It is just similar to a line chart. Okay. And what is the major difference is? That major difference is, while line graph connects the data points with a line, scatter chart simply plots the data to show the trend in the data. Okay. Whatever the data points are there, okay, that data points will not be joined with a line segment. Here what was happening in the line chart, that whatever the values were there, that were being joined with the help of a line segment. Okay. It may look like a straight line, it may look like a curve, that depends upon the values of the data. But here whatever the points are there, that will be scattered, and there will be no line which is joining these points. Okay. That's why it may appear like the data points are scattered over the graph. That's why the name is scatter plot. Okay. Now this Scatter chart simply plot the data points to show the trend in the data. Okay, so trend in the data, you can understand that the what is the pattern of the data which is being followed. Okay, here you can have an example also of scatter plot. You can see values are given on the x and y axes, and the corresponding plots have been scattered according to the functions which is given. Okay, and these scatter dots are showing that scatter data points. Okay, so let's move further. Creating line charts and scatter charts. Okay, so first of all, let's talk about the line chart. As we have discussed, that it displays information as a series of data points which are called markers, and these are connected by the straight line segments. So here we are an example here, that creating a graph of values versus square of their values. That means if you are given with some values and you want to show a graph that it whatever the square of these values are there, that has to be represented on y-axis, and the values of the data are given on the x-axis. Okay, so let's see how we'll do it. Suppose we are having a list here. A is having the elements 1, comma 2, comma 3, comma 4. B is an empty list. Okay. For A in A, as you have discussed in class 11, that whenever we are using this list has to be given some values. Okay, and if that empty list is there, you have to append the values in that list to get some output. Okay, so here we are having a list, and in list A there are values 1 2 3 and 4, but in B there are no values, it is empty right now. So if we are writing this line, that for A in A, so what it will do, it will iterate in the elements of the list. Okay, so first small a will have one of the capital A, then the loop will execute for that things. Okay, in the next stage this small a will be having 2 of capital A, and then the loop will execute. Similarly for the next, small a will be having 3 as the value from capital A, and it will continue. Okay, for A in A, B is equals to A asterisk asterisk 2. Now these two asterisks are showing that you are calculating the power. Okay, so whatever the value of A is there, you are just having a power of 2 of that, so it will calculate the square value. It will go in small b, and this small b has to be appended in the empty list capital B. Okay, so it will calculate the first square value of 1, and it will just append it into the empty list B. Then similarly it will take out the square of 2. Whatever the square of the 2 will come, it will append it in the empty list B, and similarly one by one these elements will be appended in the capital B list. Okay, now after that we have written pl.x label values, pl.y label square of values. Why these labels are used? It is used for showing the labels on the axes. Okay, so obviously you are going to have two axes in the graph. If you are plotting 2D graph, you will be having x and y axes, and these x and y axes have to be provided with the data labels. Okay, so for x we are giving the label as values, and for y we are giving the label as square of values. And after that just we are going to write pl dot plot a comma b. Okay, now let's see what is going to be the output here. See, this graph has been plotted. Okay, now as you can see, in x-axis the label is given as values, and for y-axis the label has been given as square of values. Okay, now for 1 we are having the output as 1 only, because 1 square is 1 only. For 2 we are having 4. For 3 we are having 9. For 4 we are having 16. So it can be shown from the graph as well. Okay, so you can see, by seeing just the graph we can get the data about whatever the things have been given in the program. Okay, so you don't need to show the program to someone, you don't need to show the statistical data to someone. You just show the graph, and the person whoever is seeing it will be easily able to identify whatever the trends in data is there. Okay, and that's why also we are using this data visualization. Okay, now let's move further. Applying various settings in plot function. Okay, now see, the plot function allows us to specify multiple settings for our charts slash graphs such as color, marker type, marker size, etc. Now see, whatever the example we have seen earlier, the data was shown with the help of the graph, but the data values were not marked. Okay, means we were not able to identify that where these values are there. Actually, we just have to calculate the trend in the data, and we just had to set an estimate that yes, this should be the value of this should be the value of this. Okay, no points were shown there, so that we can easily clarify that yes, this particular value is for this one, this particular value is for this one. Okay, so to make this graph more attractive and more understanding, we can use these elements here, that is the color, marker type, marker size, and furthermore things are also there. Okay, let's see the previous code. A is equals to 1 2 3 4, B is equals to empty list for A in A, B is equals to A asterisk asterisk 2, B dot append B, PL dot X label values, PL dot Y label square of values. Till here the code is to be same. Okay, now the next line was PL dot plot A comma B. Now let's mark this as a comment statement, and in spite of this statement we are going to use this statement, that PL dot plot a comma b comma r. Okay, now this small r represents the color. Okay, for here it is a symbol of red color. Okay, similarly if you want blue color you can write small b there. Okay, if you want green color then you can write small g there. For black it is small k. Okay, so whatever the color you want you can specify there as an argument. Okay, also we have written comma marker is equals to o. This o basically is showing marker is equals to circle. Okay, you must have seen that whenever you are drawing any graph there are certain points in your graph, and whenever you are trying to show that data values you are just showing it with the help of dots. Okay, or the circles. Now this o is representing that circle. Okay, also you've written marker size is equals to 5. This marker size is equals to 5 is showing that what should be the width or the height of that marker. Okay, suppose if you would have written 3, the dots may appear a bit smaller. If you have written 5, it will be a bit bigger. And similarly, if you are going to write marker size equals to 10 or 12, it will keep on increasing the diameter of that dots. Okay, the height and width will be adjusted according to the marker size. Also, we have written marker edge color is equals to blue. So marker edge color means whatever the marker will be there, an outside edge of that marker will be shown, and that is to be shown with a blue color. Okay. So don't worry if you're not able to understand this right now. We will be seeing the graph of the output. Let's see. Here is the graph for that. You can see in X level we have given values, and in Y level we have given a square of values. And see, in the earlier graph which we had plotted, only one blue color line was there, no marker were specified. Okay, so it was a bit difficult to check whatever the values are given, so it has to be estimated according to the graph. A bit of calculation was there. Okay, but here you can directly see the graphs, and you can just identify the what are the values of that x-axis and what are the corresponding values of the y-axis. Okay, so that is the use of this color, marker type, marker size, and whatever things are there in that specific arguments. Okay, now let's move further. Suppose a second example is there, drawing line chart of sin x and cos x on the same graph. Okay, now this is a bit calculative thing. You have to keep your minds open to just understand the codes here. Okay, import matplotlib.pyplot as pl. Okay, this statement is being used for just importing that matplotlib library. As we know that whatever the pyplotting is to be used in Python, that requires a matplotlib library, so we are just importing it, and pl is the alias name. Okay, after that we have written import numpy as np. Why we are using numpy here? Because we have to use the np, that means the numpy functions here like arrange and whatever is there. So without this NP we cannot use those functions, so we are importing NumPy also. One more thing here we have imported is import math. Okay, I'll be telling why we are using math here. A is equals to np dot a range 0 comma 2 into 180. This also I will be telling you that why we are using 0 comma 2 into 180. Now again B is an empty list here, C is an empty list here. For D in A, D1 is equals to np dot sine math dot radians D. Okay, try to understand this very carefully, that here what we are doing is we are writing d1 is equals to np dot sine math dot radians D. Okay, now, whatever the function of sin x and cos x is given, the values of x are taken in radians, okay? But we need to give the values in that form of degree also, because whatever the things are there, we just remember it with the help of degrees. That sin 30 is this much, sin 60 is this much, sin 90 is this much. So it will be easier for us that if we give the values in degrees. But since sin x and cos x is taken as in radian, so we need to convert this degree into the radian, and for that sake we have to use this math dot radians, and this math dot radian is only to be used when you are having import maths. That's why we have imported the math library also. Okay, so I think you must be understanding why we are using import math. Okay, now import math, then d1 is equals to np dot sine math dot radians D. It will calculate the sine of the given values in D. Okay, and what D is? D is just iterating in A, and A is the set of the values in degrees. Okay, so what this small d will do? It will just take us degree from this range. A is equals to np dot a range. Then that particular degree is to be converted in the form of radian, and then once it is converted in the form of radian, it will be given in this sine of that particular value, that sine of x. Okay, and then once it is converted in the form of sin x, we can just plot it with the help of graph. Okay, similarly in d2 also we have given np dot cos of mat dot radians D. Now this cos will calculate the cos x of the given values. Okay, similarly the mat dot radian is converting this degree into the radians form. Then again in the previous codes we have used that append function of the list. Here also we are using the similar function, b dot append d1 c dot append d2. Okay, so whatever the values are going to come in this d1 and d2 will be one by one appended in this empty list, small b and small c. So small b will have a set of values of sin x, and a small c will have the set of values of cos x. Okay, and these values are coming iteratively, that means one by one in each every step. So whatever the range is given 0 comma 2 into 180, so all the elements between 0 to 360 will be coming in this range. Okay, and for each particular degree, each degree will be converted in the form of radian. Okay, and that will be shown in the graph of sin x and cos x. Okay, again we have written pl dot x label angles in degree. So in x we are showing the angles in degree, and pl dot y label values. Here y will show the corresponding values of sin x and cos x. Now we have written pl dot plot a comma b comma small b. Again if you remember, the third argument which is passed inside the plot is the color argument. Okay, so we are showing the sin x graph with the help of blue color, and again the next line we have written pl dot plot a comma c comma r. So we are showing the cos x graph with the help of this red color. Okay, and the next line we have written pl dot show. So let's see what is going to be the output. See, here we are having this output. Okay, so in just as one graph we are showing two graphs actually. Okay, these actually are the line charts of sin x and cos x. So as I've already told that blue is used for the sin x graph here, and red color is being used for the cos x graph here. So you know that sin 0 is 0, cos 0 is 1, and similarly the values of the degrees have been increased, and accordingly the sinusoidal and the cos graph can be seen. Okay, and you know that this values of sin x and cos x varies from -1 to 1. So you can see the range of y-axis is between -1 to 1, and it is varying accordingly. Okay, so I don't think it's a problem now. I think it must be clear to you. So let's see some assignment for you today. What you have to do is, first you have to create two line charts of functions tan x and cot x on the same graph. Each must be having colors of graph line as red and blue. That means for tan x you have to show the color as red, and for cot x you have to show the color as blue. Okay, it will be very easy for you. You can easily do with the help of that degrees and radians and functions which we have used in the previous example. Then second one is, create line charts of A versus B and B versus C. Okay, be very careful with this. We have written A versus B and B versus C. Okay, where A, B, C are arrays of A, means A, B, C are arrays. Okay, and A consists of numbers from -5 to 5. That means -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, and 5. And B consists of values of mod of A. Okay, and you know what mod does? It just converts all the negative values in the form of positive values. Okay, so B is consisting of mod of values of A, and C consists of square roots of values of B. So whatever the values are going to come in this -5 to 5 is will be converted in the form of mod with this B, and the values inside B has to be taken the square root, and this should be specified in C. Okay, and most important thing which is to be noted here, that you have to specify the marker as circle and its edge color as red. That means you have to use that as particular specific arguments which we have used in the previous example for the marker. So for giving the marker, you have written marker is equals to O, so you will use for that, as for specifying the marker as circle, and edge color you can give that red. Here edge color is marker edge color. Okay, don't be confused with the edge color. Edge color means marker edge color, so use the marker edge color as red. Okay, so I think that's enough for today. We'll be meeting in the next video lecture. Thank you, students.